So much, gentlemen, for joining us today, and thank you, Nikhil, for really setting the context, the structure for our conversation. Um, we have about 54 minutes or so, and we will try to do as much justice to this as possible. I know that I have to just get out of the way because what you see in front of you are founders who are really representing the full value chain of space that can possibly be. Building on what Nikhil was saying, last we checked, there are about 200 space tech startups in India that are operating across the value chain. And what is this value chain? Begins with upstream, building of rockets, building of satellites, midstream, which is really the in-orbit economy, and then downstream, which is really applications of this data, multiple use cases, and so on. Our panelists actually represent this entire value chain. We've got PierSight building satellites. We've got Astrobase building testing infrastructure and rockets. We've got the midstream, which is elongating life cycles of infrastructure out there. And then we've got a whole gamut of downstream use cases, which I think PierSight is also going very, very aggressively after. Over the next 45 minutes or so, gentlemen, I have a few questions that I may ask, and then at the end we will open this for the audience. We'd love to know what are your curiosities and so on. I also want to maybe just, at least my observation, about why is a conversation on space tech important, because this is a very, very different space, and this pun is very intentional. The regular rules of building a tech company do not apply to space. I mean, it is a very, very precise science. The usual principles of design thinking, while Arindrajit, you speak a lot about frugality, apply partly and very differently in the sector. And all of that, I think, deserves a conversation. All of that is something that all of you have grappled with. And that's what I'd be really keen to bring out today, which is the specificities, the real stories of what you've grappled with. How have you overcome, some of the challenges that are very space specific, if we can bring out today. So then this panel, this conversation becomes more informative. And maybe we will scare you, maybe we will inspire you. We don't know that yet. But at least what we can promise is we will inform you about what's really happening out there, and perhaps give some ideas of what to do next if you are aspiring to build for space, or if you're aspiring to invest in space. That's going to be, I think, the most I'm going to talk for the next 45 minutes. But for me to begin with, maybe the same question to all of you, which is, for each of your companies, of course, tell us what is it that you're trying to solve. Describe your company and your big problem statement, but also tell us one key insight about your specific domain or your problem statement that you've discovered, which 95% of our people in this room would not know about. Tell us one new thing that you've discovered, that you've tried to solve for, may not have solved for yet, that may be new to our people here. Arindrajit, could I begin with you?
Hi, good morning everyone. I'm Arin. I'm from IIT Bombay. I have still not left my position as a professor there, trying to. But I'm strongly involved with Inspecity for the last 3 years and plan to continue to be there. I think this is a very hard question. Most of her questions are very hard, for the record. I don't know how you guys will handle this, but yeah. Right. Distilling all of this insight into something called ISAM, In-Space Servicing, Assembly and Manufacturing, into a single word is tough. But to a degree, out of ISAM, Inspecity's initial goals are towards life extension of satellites. And the key insight that kind of surprised us, should not be very surprising, but still surprising, is the rate at which satellites, don't function well in space, right? They're such complicated beasts, and I think Gaurav handles this, and on a regular basis. If you look at satellites, there are so many subsystems that are very intertwined with each other, and the intertwining is so strong that if one of them kind of stops working, the entire satellite stops working. So this was kind of a revelation, and the rate at which the new space satellites fall into this a problematic area is surprising. I believe that this is definitely being worked upon, and we are trying to work upon reliability of these systems. But when we produce at scale, there is going to be a percentage that is always going to pop up, and that percentage is something which cannot be completely mitigated, right? And those percentage of satellites are going to fail. And when they do fail, the revelation on the back of that is that what happens then? If they are somewhat further up in orbits, the closer you are to Earth, the faster you deorbit naturally, because drag, solar wind pressure, different forces pull you back. But further you are, and you'll be surprised, just a little bit, just 50 kilometers being up can be the difference between deorbiting within months and between years. And another 50 kilometers up will take you to tens of years, and another 100 kilometers will take you to hundreds of years, which is very scary. So further you go up, and suddenly somebody has an idea, oh, this area is crowded in low Earth orbit. Why don't I put my satellite up there, further up? The further up it is, and if it fails, it does not come back by itself. And by chance, there is a collision out there. And this happened 2009 or so between a Chinese satellite and a Russian satellite. US satellite and US, Chinese, Russian. Okay. I should know this, just, bear with me. Right, so bad my brain has blocked it off, maybe. Okay, but anyway, stepping back. So this happened, people did not really think that this was going to happen, but the probabilities are minuscule, but it just needs to hit once. And that entire range of orbits become unusable for decades to come, right? And at the back of this, just to clear out, at the back of somebody putting up a bunch of satellites in an area where one fails or several fail, and one of them hits another one, and it goes. This leads to a series of chain reactions in some way. It's like a nuclear fission. Right, so one debris goes and hits another one, generates 10 debris, and another 10 generate 100 debris, and there is a name to it called the Kessler syndrome. So there is a scientist out of JPL who came up with this idea, and they just recently published one more saying that the probabilities of things going wrong have just climbed another level because of the activities that we are going to do. And this is something that was as a revelation, and as much as we should take care of this economy out there, we should really go towards 44 billion and more, God willing. But at the back end, we should also think second law exists, second law of thermodynamics. There is going to be waste. There is going to be an inefficiency that you cannot wish away, and figure out a way to deal with it. That's it. Okay.
Sorry, what was the question?
Tell us, what is PierSight solving for?
Yeah.
Why is that a big problem statement? One key insight that all of us will not be aware.
So PierSight is building a small satellite constellation to monitor all parts of the oceans at all times. So the case for small satellite constellations is pretty obvious, that the camera you have on your phone, if you put it on a satellite which moves at 20 times the speed of sound, you'll be covering rapidly most parts of the Earth, right? And small satellite constellation right now makes a lot of sense, because almost a rocket is going up every day. Thanks to AI, you can understand all of the data. Thanks to 5G, things are getting miniaturized. So yeah, that's where we are at the intersection of all of that. And we build a satellite having a specialized camera called synthetic aperture radar, whose USP is that it can see through clouds and image at the night time, right? So something I think insight we see very differently is that when you're trying to do something very, very small, you also have to try to do less. Because if you try to make a small satellite and try to cater to everything a 2000 kilogram satellite does, you'll fail in one way or the other. Laws of physics will come and catch you. That's why at PierSight, we started with a focus on application specific SAR satellites, that if you have to make it small, try to do less, concentrate on a single application, which anyway is 70% of the Earth. So, big enough market.
And before we move on to you, Neeraj, this is not a question that I sent you, but I'm going to still ask you this question.
Yeah.
How long does it take to build a satellite?
It takes, the first one anywhere between 2 to 3 years, because the first one is the most difficult. And post that, you can very, very rapidly proliferate. So just like any other R&D,
So if a satellite is lost in space, there is no way to make up for the time. You could make up for the financial loss, but the time lost is time lost.
In a way, but of course, you also qualify the people on ground to build hardware for space, not just the electronics is space qualified. So I won't say that you lose everything. Of course, the capability remains, and next time you build a second satellite, you won't take 3 years. You'll maybe take 4 months.
Fantastic. Neeraj, we move on to you.
Yeah, thank you. A quick introduction. So, I'm from Rajasthan, born and brought up there. Did my engineering from IIT Bombay in 2012, electrical engineering. And in 2018, I started CoinDCX, which is today one of the largest blockchain technology company in India. Many of you would have accounts on it for your investments purposes. So, and in 2022, I realized that US and other countries in the world are progressing very rapidly. And today, just an example, US is launching 5,000 tons per annum to space, various things. That's the per annum, and that's only going up from here with the more launch vehicles coming into picture. So it could potentially go to up to 50,000 tons per annum in the coming years. Similarly, China is currently doing couple of 100 tons per annum. They are sending that much to space today, and that's also increasing rapidly. India, currently, though we have excellent capabilities, but we are currently sending 5,000. Compared to that, we are sending only 20 tons. So that's our current 10 to 20 tons. And in 2022, I also went through the ecosystem. So say with Skyroute's vehicle also, we will add per annum, if Skyroute is doing 12 launches or maybe more, it will add maybe 5 to 15 tons with the current vehicle setup that they have. So, which is a great progress. But so I thought I should use my experience also to contribute to this problem statement and take our launch capacity purely in terms of the capacity to very quickly beyond 100 tons as a first step, and then take it to 1,000 tons as in the next iteration. And the assumption there is that we have enough material to sand. I mean, of course, the industry is growing, and it's a chicken egg problem. If we don't have the capacity, then we'll never have the material to send also. So it needs to be solved either ways. And that's why the Astrobase, I started Astrobase along with some experienced propulsion scientists from who have left ISRO and joined Astrobase to because I see this as mainly a propulsion problem and a manufacturing problem. So propulsion and manufacturing scientists, we have partnered and started the company. First focus is to have one single engine built that can power this entire 1,000 tons journey. One single engine technology, propulsion technology, that's enough. You don't have to reinvent it again and again. That can do this. which has been also been proven in other countries. So that's the focus area, and we are close to achieving those milestones. Last 2 years, a lot of work has been done. Yeah.
What's that one insight?
One insight is in this launch vehicles, the vehicle itself is not very expensive. It's actually a manufacturing problem. Very counterintuitive. Most of the investments, most of the time, most of the money goes into setting up your production facilities and production and testing facilities. If it takes 100 million to launch, as a company, if it takes 100 million to reach the orbit for the first time, the rocket itself will cost 2-3 million, 4 million, less than 5 million. Rest of the money actually goes into manufacturing base, your operational expenses, your test facilities, and all of it. So it's more of a to reach the space, you have to strengthen the ground actually. So that is the key learning that I've also had in the past few years.
That's very fascinating, and I will dig deeper into the manufacturing problem in just a bit, but we must hear from the only or the biggest downstream voice, at least on this panel.
Thanks for that compliment. Good morning, everyone. So, one liner, what we do is we are building a tech for a large-scale impact. And let me just little deeper into it, and first why we are doing it. So let me just give a glimpse on the problem statement. So we work in water, agriculture, disaster, and city building tech for solutions on these areas. And take India as an example. So there would be, I would say, 1 million water bodies which human or people are managing, where water is getting stored. As India as a whole, close to 1 million plus. Now water is being stored for use to close to 100 million houses. So that water needs to go to 100 million houses plus. It needs to go to close to 500 million farms. So think about it, that is happening currently. If that doesn't happen, we have so many news. So that's the magnitude of the operational challenge. And India doesn't get water all the time. It's a monsoon, and then you have dry periods. So you need to store, manage. And if you don't manage, of course, inefficiency takes in. But given the growth stories that we have, given the sectorial participations in the growth, water is a very pivotal role to play for the water security of people, water security of the food that country needs, water security for the industry, and other associated growth. So we are building tech to do all this. And just on the agriculture side, very similar a number problem if I present is those 500 million farms needs to be very productive. Right now the productivity, I think India is one of the lowest in farm productivity. What are the problems? Right from managing the right inputs, seeds, timely interventions on the field, and associated climate advisories, adversaries. And these adversaries, right from if the farmer is sowing and all of a sudden a huge cyclone comes, his entire crop is gone, to if a drought prolongs, the crop dies. If a pest proliferation happens, again the crop dies. And all of them, even if survives, with a low yield. So how do we make sure this 500 million is being a data driven and translate into a higher yield, more importantly going future with less chemical traces, because we are also feeding a lot of chemical into the entire chain of food. So to do that, now we need to build a tech which is not just looking at a state scale, district scale, but actually has translated into a farm scale. Then only these interventions can actually happen, and a farmer can relate to him or her and take these advisories and act upon them. And these climate and the climate situation as it is unfolding, in the last, I think last gone year of monsoon was a very surplus year, and we have seen while the water was surplus, but it also translated into huge amount of floods. Perhaps the northern Himalayan states were one of the worst affected with cloudburst, landslides, and we were building solutions to predict flood, to predict cloudburst in real time in advance of 7 days. And again, we need to do it almost for the whole of country or a large area. Then only you will be, you don't know where it will happen. You cannot just focus and do for that area. So to do all this, think about there are 2-3 major problem statements to be really solved while we see that there is a tech to be built, but it needs to be done at a scale, and you need to have a data actually to really be able to translate all these problem statement into a digital solution so that somebody can act on it. And we have been working in this space for the last 10 years. I would say thanks to space sector, because one of the big problem of data was solved in the space. So how do we know what's happening in those 500 million farms? The answer lies in space data, satellite. Thanks to a lot of satellite and reforms that has happened in the recent past. How do I know what's in those 1 million, how much is the water in those 1 million water bodies, and are they healthy, which lakes are getting dried up? Look into historical data and analyze. Again, we got the leverage from satellite. One of a very recent, we are doing one work in Andhra Pradesh. Again, we are working with a lot of states, but one small problem that came was related to a tidal subsidence. I would not name because it's still in the discussion and it has a lot of political sensitivity to it. But they were not able to prove what has happened there. And we were able to fuse data from interferometry data, optical data, and a lot of historic data point to say where exactly a subsidence has happened and where coastal insurgence and lands has happened. So all these problem statement is translating into one is the data. Pre-space era, this was taken up by sensors, IoTs, which is still required. But as we talk about how do we take it to the scale, this huge amount of satellite data is to be leveraged. And we're talking about, in this season when we are working with the states, we have handled close to 100 terabytes of data in one state. Now that data needs to be translated, so you need to process them. Data engineering is huge, and these insights needs to be taken not by people, but through machines. So automation is to be done. And that's where we build a huge, I would say, data engineering and automation platform to harness the potential of this data. But also, now we are not just at the data to information, but we need products for all these different sectors. We need a product for farmer, because that data translates in a very different form to the farmer, and there is no relevance of what was acquired in this satellite. So we need to translate into farmer. We need to translate that data into agriculture officer or a government policy maker, and similar story in the water and disaster sector. So this challenge is what we are solving, and yeah, we are, I think, in a continuous learning over the last 10 years, how every 2-3 years a new problem statement has been coming.
Got it. Thanks, Nikhilesh. At least the three of you, Neeraj, Gaurav, and Arindrajit, I know you're, I mean, there is to build on top of what you were saying, a manufacturing challenge that each of you have seen, or at least are seeing in different forms. Talk to us about building hardware. What are the different components that need to be solved for? There could be, and the Q is supply chain, talent, just timelines. What does it look like to manufacture satellites, to manufacture rockets? Hardware that you may have very little references for, or there isn't an ecosystem that exists that you can readily tap into and build this out. what's happening there, and have you seen any wins, something that you're trying that has been working, which other companies could lean on? Neeraj, beginning with you.
Yeah, I can start. So, manufacturing is very exciting, by the way. It's very exciting problem to solve for India. I'll give you an example of rocket engines. Okay, rocket engine manufacturing, and some data points around what it takes as we are progressing into it. Uh, some base, 100-ton vehicle, a vehicle that a rocket that weighs 100 tons can typically take 2 tons to the low Earth orbit. Okay, so and to power a 100-ton vehicle, which will take only 2 tons to the low Earth orbit, you need 1.4 times the thrust at the bottom, which means you need 140 tons of thrust at the bottom of the rocket. So that means you need engines that can give you power of 140 tons at the liftoff. Now, to manufacture these engines, how much capex do you need? So if you want to manufacture this kind of, say, engines, only for one launch per annum, you need 100 crores invested just in the capex. Only to do it one time per annum. That's this. Now, if you want to take it to 10 tons, suppose, just crack the problem statement of taking 10 tons to the orbit, you need 5 times, 5 of such investments, 5 lines, manufacturing lines. And that essentially means 500 crores. Sure, you can optimize it a little bit because you are doing it a little bit more. So, in the range of 400 to 500 crores of investment just to manufacture the engines for taking 10 tons to orbit. So, these are some of the real numbers, and that is why it is hard and a difficult problem statement. You need. Now, let us talk about the timelines also. When you are setting up such manufacturing facilities, just getting the land for it takes months and months. Then the infrastructure, the clean rooms that you need to have in place. If you are using 3D printers, it takes 1 year to buy a 3D printer. It's not like, okay, go to a mall and buy a 3D printer, right? It takes 1 year minimum. From the day you decide, okay, we have to buy a 3D printer, it takes 1 year. And to run a 3D printer, you need to have a team. And today, if you start thinking about building a team, it takes 6 months to just build a team, if you get it right. And then when the 3D printer comes, you have to start and set it up, and there are so many things involved. So it takes a lot of hard work and this kind of capital to solve the problems that we want to solve, right? So it's not. So this is what I will say about manufacturing, but I think India needs to have maybe my estimation is just in the space related manufacturing over the next few years, we need to invest 10 to 20,000 crores in establishing manufacturing capacity. We have the capability, like we saw in the presentation also. We have the capability, but we lack the capacity. So that needs to be built, and this is the quantum of investment we'll have to make it happen. Yeah.
Thanks, Neeraj. Gaurav, I've had the privilege to seeing some of the early, like only you trying to tinker with some things and then initial team, and then you're moving into a bigger facility and so on. Talk to us about these different stages. What were the different challenges, starting from zero all the way to where you are today?
Yeah, in fact, I'll take on from where Neeraj left. I think it will be perfect cue. So we build satellites, but we don't cut metal at our facility. Our main job is to design these satellites, integrate them, and ensure that they work together. As he was correctly saying that in a rocket you only send up 2% of the mass, right? and all of that 140-ton thrust, a satellite has to handle it. You need to ensure that it doesn't die within the vibration or that shock, and once it goes up, it works fine. So that is the biggest challenge, and a satellite is a very dense mass with very, very fragile electronics, and specifically for a small satellites, you can't really have multiple redundancies. So you have a lot of single points of failures. So the real trick is to get it all working together, all of it at a single time, right? And when you do that, you need multiple teams in house, which is the biggest challenge. Like, we are a small company of 60 people, but we have 9 divisions within the company. I mean, like, there's electrical engineering, people would know about power electronics. Space-based power electronics is a very specific field. Then you have very specific kind of software engineers who code beyond the screens on FPGAs, and very, very, very typical things where it's rare to get the talent, very difficult to retain them, and then ensure that everything works correct, because only a single thing doesn't work right, and all of that years of effort, not only of the satellite but of that 100-ton mass which went into the rocket, all of that fails. So that is the real challenge with the satellite, to have it work reliably.
No, absolutely. And I'm going to pick on that. If you have a comment to make before I ask you your question, go ahead. Yes.
I was going to say nobody knows, but yeah, 2 seconds.
Yeah.
2 minutes. Very glad to see Neeraj come out and do this. There is this crypto billionaire called Jet McCaleb out of US who is building a company called Vast about building space stations in space and then large rotating O'Neill cylinders in space. I've been in awe of him coming out and doing this. He could have just sat around and not done much. Yeah, so glad that he's there. And it kind of builds upon this. So at Inspecity, along with the propulsion side, along with building satellites, we're trying to solve for in-space propulsion, and we're trying to solve for robotics and RPO as well. And to be honest, again, I think we also don't cut a lot of metal in-house. We started cutting it. But I think what they're trying to say, I just wholeheartedly agree that the capability exists to some degree, but the capacity does not exist, and the capability to build at scale and cross-check whether they have been built in the right way and assembled in the right way, still don't know how to get it done. So I think Gaurav is trying to solve for that problem. Very different problem for space compared to launching this. And for us also, we are in a similar boat. I don't know what it takes, to be honest. But it's like asking, what does it take to liberate a country? I mean, if you ask 2 generations earlier, hey, what would you do if you wanted to come out of dependence into independence? How should you go about it? You find it out, right? You go about it and you find it out. So you start. Definitely, we are going to find this out. ISRO has built the capabilities, but this is a different class of capabilities that goes towards launching tens of thousands of tons of mass. That mass needs to be produced so that we don't go create a mess, just changing a vowel in the middle, mass to mess. That's it. That's what I want.
I also saw the professor in you come out with that provocative statement thrown just like that, and
the class will go to sleep otherwise. Yeah, right.
So yeah, I mean, that's the challenge, right? You have to build the satellite, make it work right, and then it has to be at the right unit economics. Otherwise, Nikhilesh and team can't, make money out of it. And nothing really makes sense. So that is the real challenge. And then if you're up there, you don't act responsibly, you'll have to ask Arin to come and bring you back so that you don't jeopardize the entire orbit. So yeah.
I wanted to actually pick on the last part of what you were talking about, which is talent. And talent, of course, the dearth of the right kind of talent that I've heard several of you talk about.
No, I'm not saying there's dearth of talent.
No?
No, I don't agree.
You have ample, and as in the sector, ample good talent.
It's weird if somebody says that in India.
Oh, okay.
It's 1.4 billion people and one of the smartest, we always keep saying, right, Indian CEOs. I don't agree that there is dearth of talent. Yes, of course, this is a very niche field. So you won't really get a talent which is very suited for you, and it becomes challenging in the timelines, right? You also have to work through a venture capital timeline of 10 to 12 years and produce results within. So that makes it challenging to make the talent usable. But I don't agree at all that India doesn't have good talent.
And what has been your experience of finding the right people, putting teams together?
I think similar insights. There's a clash between the team leads and me in some way where I say that no, you need to bring in fresh engineers from all types of colleges and work with them as an intern at the beginning, and then they should get into it. And then they say, but you're putting this timeline in front of me. How do I get it done in this timeline? You get me some people who are trained and who can do that thing, but getting that exact training in the way that you want is not there. The way that ISRO has trained has been in a classical way of doing things, and people who have been kind of not been very satisfied with it are sitting here and around. Oh, no, okay, maybe not. Maybe that's too far, putting words in this side. But that aside, right. But that's a different way of doing things, and building in a way that can be scaled up or built very fast is still tricky. And I don't think India has that kind of talent in India. That talent exists in US to a degree, where if you want to start building a satellite from a blank sheet to a fully built design, you can do this within 8 months to a year and launch it. So hopefully the H1B issues kick in and we get some of that back, right? And then we have the ability to absorb some of that, right? So that exists to a degree, and a new company like his company would be able to absorb maybe 50, 60 odd people from the ecosystem immediately when they start. That is not there. A lot of fresh talent is there, very, 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 very good, very, very, with very high potential, but how to make it useful and how to absorb into the architecture is a very good question.
But that is what ISRO cracked, right? ISRO never had, it just used to hire mechanical, electrical and other normal engineers and convert them to space specialists. So I think we can't shy away from that as the private industry.
Oh, absolutely. And the number of space tech founders that have a history with ISRO is a pattern, for sure.
And I didn't leave ISRO because of any issues. So it was very clear.
No, a great learning ground, for sure. Yeah,
absolutely. It was life changing. In fact, what I am, everything is because of ISRO. I left particularly because, I wanted to do something commercially, and they had a different direction and different policy. And this made much more sense.
Yeah, no, absolutely. Go ahead, please.
Just a small point on talent. I think, I believe that India is the greatest country to ever exist on this earth, the oldest civilization, and there is no problem of talent, of course. The problem exists, but it's not the talent, it's the misallocation of the talent. Just one example from my experiences, sir, is in CoinDCX, we have a team of 650 people, most of them in the software. It's a software company at the end of the day. And as soon as we release a senior software engineer role on the careers portal, within 1 month we receive 5,000 applications. And hundreds of them are very well qualified for the same job. I have not seen the same thing happening when we are doing the Astrobase. So those are also Indians, right? So the talent is misallocated at the country level for things that are built for convenience, right? For example, food delivery, all good businesses, food delivery, cabs, and there are so many software companies, fintech, and the talent there is humongous. And so it's a misallocation problem. And the core reason for that is simply a 5-year experience after an IIT in the software domain will give you 70 lakhs, 60 lakhs, 1 crore. Sometimes the introductory package is 1.5 crores, right? Which is right after the college placement. And if you go to hardware industry, something that is very important for the country, this is not the case. That's the problem. So the money that you get is low. You reach 250 lakh point maybe 1 decade. down the line, mandatory. There is no way to just, and that is the problem. It's a resource misallocation problem, which I feel is going to end very soon, because artificial intelligence is going to just bring the salaries in the software field down so significantly, because now instead of 10 developers you only need one, right? So that is becoming heavy on supply. Talent supply is becoming too much on that front, and people are realizing it. So it's a matter of time that talent will get allocated to the right things faster. Yeah.
Good, of course, so you definitely should add to that. But Nikhilesh, we were talking about the distinction between the user and the customer. In especially the business model that you operate in, give us some insights on how have you cracked that piece, because that may have implications for others that are thinking about similar business models.
So I'll take two questions in that case. Let me add and build to it. I think I agree to Gaurav that definitely dearth is not there, and we have been like for 10 years operating and building. We have 300 plus. So definitely the talent has been there to allow to do that. But where is the problem? Also, I would like to highlight. I think all the people here are kind of solving a 99 percentile tougher problem, and by the virtue of you are in the space of a problem statement where that ecosystem is not in India. And if I compare, if I don't see the salary, and if I have to hire somebody from India versus let's say an ecosystem in states, perhaps I'll hire the person in the state, because there is definitely that person, a person in India versus the person there is a big talent gap. It's not about the intellect, but when you say talent to that relevant sector, can the person translate and solve the problems? I think that ecosystem has not been here in India. And we also have from IIT, we also have from IIMs, freshers, translate them. But that translation process takes time, couple of years till the guy get matured to contribute. And by that time, the person leaves also, right? So that is, I would say, put you into a shoe of where you're chasing for the talent. I think that's what I would just leave it on the talent side, and which is where I think opportunity lies in the academia. For how do we bring relevant? One is the basic disciplines, but how do we also merge towards the frontier technologies, which is what we are targeting, so that candidates are in a better situation and we save some couple of years before they start contributing.
One very quick anecdote. There is a guy from IIT Madras in the team. So we hired him about 3 years back. So his father came and said that I pay my peon more than this. His father is a lawyer. Whatever we were paying him at that time. So I didn't have any money. They said, I pay my peon more than this. Please release my son. What are you doing with him? So I said, give me some time. Let me raise some money. Then I can give him more money, definitely. He's happier. He's still sticking around. His father seems to be calmer. His sister is an MBA from IIMA Ahmedabad.
Yeah, I'll take on the other problem or point both, I would say, is that in the downstream side, the users are many. I just gave the example of 500 million plus farmers, and we have solutions which are in disaster, perhaps so much use cases we are already serving to the citizen, to the industry, to the government. But when it comes to the revenue model, there is a big challenge. Number one, the overhead to deploy such solution is pretty high, because you cannot like build a solution for one farm. You have to build at scale so that it happens. So there is a big overhead on the tech, on the manpower, on the infra, on the data, and also the science needs to run in together. You can't actually do it for one farm or just few water bodies and few areas to predict cloud burst. So when we do that, the cost is high, and we don't have a takers where we build these platforms and then farmers would come on board. Perhaps the today in the country we have a like a lopsided pyramid where the use cases are more on the top side, but they are not payers. And being like we are bootstrapped, so we have to survive. So we figured out how to solve that problem where we navigated through the different user groups, and we found that today government is one of the highest taker on this area, and whether it is agriculture, water, disaster, even city, we are doing encroachment monitoring for city municipal corporations. So we figured out that it is primarily government who are takers. Now the biggest problem is being a startup working for a government is like, how do you crack tenders? That for the first 5 years we just barely survived, and getting tenders was one of the, because for cracking tender you need to have 10-year experience. You're 5 year, and they ask you should have done those works. We haven't done any. So
how did you crack tenders then?
yeah, we figured out.
How?
That could be a longer conversation. But yeah, we did. Perhaps if any tender such comes, not just in India, even at a globe level today. So we are working in Saudi Arabia through tender. We are working in a couple of other countries through tender. So we did crack it, and we found a scalable. I mean, like unlike the typical anecdote, B2G is not scalable. We found a scalability in it, and how the revenue model can be, I would say, smoothened out. Beyond that, we also are figuring, and we have done some headways into it, is how do we translate this into a bit of PPP? And as the country is going through DPIs, and we are building a couple of DPIs in agri and water, and we have partnered with one of the state government of Kerala, where we are building an agri DPI for them, where there is a co-partnership where we have put a capex along with them, with the government, and there is a revenue stream to recover the capex and operational and have a profit margin. So we are also reinventing, and this is where policies, regulations, and how it would turn around needs to take a shape.
Thanks, Nikhilesh. Very, very useful. Nikhil, there are many submissions that we made today to InSpace. And we'd hope to take the conversation forward.